Dear students, today we will discuss how to handle competition between processes. As we have learned that different processes are being executed in a multi-programming fashion. So, time slot is given to a process and then multiple processes are being executed at the same time. And if there is a case that one process demands a peripheral device, for example, printer, so that printer will be given to that process. If at the same time another process also demands for the printer, so then what will we do? Maybe we need to wait until first process finishes its execution. But how to handle such competitions? And there are some other issues as well when we have multiple processes and multiple resources. So any resource can be demanded by any process at any time. So it should not be the case that there are certain issues that same resource is given to more than one processes. So it may happen. We will learn about it. So resource allocation is important task of operating system to allocate resources like peripheral devices, mass storage, main memory. So this is mass storage is also one kind of resource. So one process want to access a file and another process also want to access the same file. So process 1 want to read, process 2 want to write. So will you allow the two processes to access or retrieve the same file at the same time or not? And similarly, if we talk about main memory, so if a process A is writing something in the main memory and at the same time process B also want to write or read something from the main memory. So we need to learn that are there some well-known issues when multiple processes share multiple resources. So there are some other examples of resources as well, like file manager allocates access to files. Memory manager allocates access to memory space. Scheduler allocates space in the process table. So it may also happen in the scheduler process that if there are 10 processes which are available in the process table, and then each process is going to initiate another process before finishing its job, and we have no memory available. So this means that we are out of the memory and the process which is running right now want to initiate another process. So this means we are in a trouble. So similarly, dispatcher allocates time slots to the processes. So such resource allocation looks quite simpler, that we will take the resource from which is available free and will allocate to a process, and if that is not available we will ask the process to please wait. However, it is not very simple, which we will be learn in this module and in the next module as well. So machine does not think about itself. So it is you that you need to design a system that is able to properly function as an operating system, and that is taking care of all of the processes, the rights of all of the processes, and is not doing anything wrong with any of the processes which is being executed at the time. So for example, I have listed two issues of process allocation and competition between the processes here. What if two processes demands the same resource at one time, like the printer or CD player or something like that? And what if process A is utilizing a resource 1 and waiting for resource 2 to finish its process. However, that resource 2 is being utilized by another process which is waiting to be finished after execution of the resource 1. So this means process 1 is waiting for process 2 and process 2 is waiting for process 1. So in this handling competition between processes, we have two very important concepts known as semaphores and deadlocks, which we will be learning in the next two modules. So if we conclude that when we have multiple processes and multiple resources, then there may arise some problems, some issues, and we need to design an operating system that is efficient and reliable enough to handle such competitive problems between the processes.